Hello! What's happening, everybody? Today we're going to look at the Chapter 9 test review, and we're looking at questions 1 through 5, uno through cinco, and let's do it. Here we go. These first 5 questions are all going to deal with area in some way. In the first question, we have a regular hexagon, and a hexagon is some type of regular polygon. Oops, polygon, there you go. I know how to spell. And the formula for a regular polygon is that the area is equal to 1/2 times the apothem, or apothem, depending on who you are and stuff. I don't know. So apothem multiplied by the capital P, which represents perimeter. So when you're doing this, you're going to have to know that's the apothem. And this is the perimeter. So remember, the perimeter is the distance around our polygon. So, and the apothem is it's kind of like a radius, but it's not the radius. The radius would go to the vertex here, but the apothem goes to the side, makes a 90-degree angle. So that's the little a. All right, and it tells me that the little a is 6.9. All right, and I've got to figure out what the perimeter is. The perimeter, it tells me, perimeter's 48. So usually you have to add up all the sides, like 8, 8, 8, 8, 8, 8, and you'll be like, okay, 8 times 6 is 48. So usually you have to figure out what the perimeter is, but in this case, they tell you, hey, the perimeter's 48. So we have all the missing pieces to this puzzle. Let's just plug in those pieces. The area equals 1/2 our little a, which is 6.9, multiplied by 48. So I'll have to use my handy-dandy calculator. Come here, handy-dandy calculator. Okay, boss. And according to my handy-dandy calculator, I got half of 6.9 times 48. And whoa, I must have pushed the wrong button because there's no way it's 1,656. That's just not right. Let me try again. Okay, 165.6. That sounds better. So the area equals 165.6, and it's centimeters, and those are square centimeters. So when you do a problem like this, you got to know the pieces. You got to know that the formula is 1/2 little a times big P. And you got to know what the little a and big P stand for. Apothem or apothem. Man, depends on who you are. Multiplied by the perimeter. All right. Anyway, so the area of the regular hexagon is 165.6 centimeters squared. Check. Next problem. What is the area of the trapezoid? You could break it into smaller shapes. You could do that. You could, because you're smart and you know things. Or you could use the area formula. The area of a trapezoid is 1/2 multiplied by the height multiplied by the base 1 plus base 2. Remember that the bases are always parallel to each other. So the bases are those sides. Doesn't matter which one's base 1, base 2, as long as it's 13 and 29, because those are the ones that go parallel. Let's get parallel. I wanna be parallel. Man, y'all are lucky to have a singing teacher. And then the height, remember the height runs perpendicular to those bases. So the height is going to be the 15 because it goes perpendicular to the two bases. So we're looking at a 1/2. We're looking at a 15. We're looking at a 13 plus 29. Do the math and you'll be fine. So, calculator. Bust out the calculator again. 0.5 times 15. I guess I should do order of operations, right? I should totally do what's in the parentheses first. 13 plus 29. Okay. Come on, calculator. 13 plus 29. All right, that's 42. Now I can multiply by 15 and 1/2. So times 15 times 0.5, and I got 315. So I had to make sure I did the addition first, in the parentheses, right? You do what's in the parentheses first. Cool beans. So I got 315, and that is in some type of units squared. So 315 units squared. Next, we got, we got a composite figure, which means there's a lot of shapes in that one shape. So we're going to be looking at all of them. Okay, I see a triangle. Hi, triangle. And I see a matching triangle over here. So I have two matching triangles. I see a rectangle, and I see half of a circle. So I'm going to start with a triangle because that's the first thing that I saw. The triangle formula is 1/2 base times height. And there's two triangles, so I'm going to do that twice. And then there's a rectangle, so I'll do the area of the rectangle, which is base times height. And then there's a semicircle, which is half of a circle. So for the semicircle, I'm just going to take the circle formula, which is pi times the radius squared. And since it's a semicircle, I'll just divide it all by 2. That'll give me a semicircle. All right, so I got all 4 of the shapes that I saw. Let's start with this triangle. I could say it has a base of 5 and a height of, oh no, if I look over here, I see that it has a height of 8. So base of 5, height of 8. 1/2, 5 times 8. Well, this triangle over here is matching. It has a base of 5 and a height of 8. So I'll do the same thing. Oops, I just wrote base and height all over again. Sorry, it's my first day. All right, and then I got a rectangle. Rectangle, where are you? Here I am, here I am. How do you do? It's 18 by 8. So the base is 18, the height is 8. No 1/2's there, it's a rectangle. A rectangle. And I'll save the semicircle for last, because we'll talk about that for a second. So my triangle is going to be 1/2 of 5 times 8. So that's 20. I don't even need a calculator for that. That's 20. This one's going to match. And, ooh, gross, 18 times 8. 18 times 8, 18 times 8, 144. Man, I'm good. Those 12 years of college really paid off. So I've got all these areas that I'm going to be adding together, but I also have my semicircle. Pi times the radius. So remember, the radius is the distance from the center to the edge of the circle there. That's my radius. And if I look up here, I see that the whole distance across was 18. So the radius must be half of that. That radius is a 9. It's half of the 18, half of the whole distance across here. So the whole thing's 18, so half of it's going to be 9. 9. So my area is going to be pi times 9 squared. 81 pi divided by 2. 81 pi divided by 2. Now, I really like that answer, 81 pi over 2, but they want a round to the nearest tenth and use 3.1 for pi. So they want a decimal answer, and I think decimals are dumb, but I'm going to do what they tell me because they're the boss. 81 pi, so 81 times 3.14. And then it says divided by 2, so I'm going to go ahead and divide it by 2 on my calculator. All right, and I got 127.17. It does say round to the nearest tenth, so I'm going to call that 127, and instead of 0.17, I'm going to round it to 0.2, because it said round to the nearest tenth, and that's the nearest tenth spot. So I rounded the 0.17 up to a 0.2. All right, so you know what I have to do. What time is it? It's time to add them up. What time is it? It's time to add them up. So add up all the numbers, and I get a number. I get 100 and, well, that's not right. There's no way that's right. Plus 127.2. I got 311.2. 311.2 square feet. So all I had to do at the end was add up all the areas. The triangle, the rectangle, the circle, semicircle. All right, flying through this. It's so much fun. All right, in this one, I've got a square that's shaded, and then I have a circle that's unshaded. So since the circle is unshaded, I need to do some subtraction. I'm going to have to subtract the area of the circle. So I'm going to do the area of the square. And I'm going to subtract the area of the circle. The area of the square is the side length times itself, base times height, or sometimes they just write s squared because the base and the height are going to be the same number. So I'm just going to write base times height because that's what I'm used to writing. And then the area of the circle is pi times the radius squared. Okay, so what do we got here? The base and the height are both 10. So the area of the square is 100. But I still have to subtract the area of the circle. The area of the circle is pi times the radius squared. So go over to this circle and take a look at our radius. Remember, your radius only goes from the center to a point on the circle. So even though the whole distance is 10, the radius is only half the distance. So make sure that your radius is 5. So the area of the circle is pi times 5 squared. I'm going to punch that into my calculator, and it tells me to use 3.14 for pi. Normally, I just like answers with pi in them, but I'm going to follow the rules this time. 25 times 3.14. 78.5. And I'm subtracting those. So my answer is going to be 100, the area of the square, minus 78.5, the area of that circle. And that is 21.5. Units squared, squared centimeters. So 21.5. So very cool, lots of area fun. One more question, let's do it. All right, in this last problem, we're going to talk about population density. Here we go. Los Angeles is a very populated metropolitan area. It's home to approximately 4 million people. The population density is about blah, blah, blah. Given that information, what is the approximate area? So to talk about population density, we need to kind of know what it means. It means the population per square mile. So population over area tells you the density, the population density. You've probably dealt with density in your science class. And I'm going to tell you, there's going to be a lot of density questions on the big exam. They like asking questions about density. So we're going to see it in terms of population. We'll also see it in other areas as well. So population density is people per square whatever. People per something. Or maybe it's like squirrels per acre or whatever. It's the amount of something divided by the area that it's located in. Population density. You will not be given that formula on the exam in May. Okay? So let's see what we got here. Let's plug in the missing pieces. Actually, let's plug in the pieces that aren't missing. That makes way more sense. This is the population. 4 million people. So I've got 4 million, lots of zeros, people. The population density is about 7,950 people per square mile. And we want to know what the missing piece is, the area. So there's we could set it up as a proportion and solve it. I know a lot of my classes like writing proportions and are good at solving them. So sometimes that makes it a little bit easier if you want to put that 7,950 over 1, and then you could cross multiply like a butterfly. One times 4 million is still 4 million. 7,950 times the area. All right, we want to solve for that A. So I'm going to divide by 7,950. All right, so I need my calculator. Oh, calculator. So my calculator tells me that 4,000,4 zeros divided by 7,950 is 503.14, blah, blah, blah. What am I rounding to? Round to the nearest whole number. So 503. So the area, A, equals 503 square miles. All right, so there's going to be more to come on density. This is not the last time you'll see it, so it will not go away. It will be here to stay. Density.